Hello, and in today's video I would like to share with you some little programming tips. First, it will be, obviously we will speak about JavaScript and about how we can easily create a class. So a class, when we think about solid principle, when we think about the single responsibility, and also about the open closed principle. So S for single responsibility of our class. So here we'll have my class will be a person, and open closed, it means it has to be closed for modification but opened for extension. That means when we want to extend our class for something different, like person, after maybe I will have a class, it won't be person, but it will be something a little bit different. So we have animal perhaps, and we don't have to rewrite everything from scratch. So we will have an interface. So here interface, and obviously person and animal, it's really similar. It does work, for instance, that's a verb, usually the function name, so the method in OOP, object-oriented programming, we call the function in a class as a method. And to work, it will return void, so nothing. And here it will extend to our interface, and our interface will be human. We can obviously change it later on. It could be something a bit different, but for now let's do human. And here where animal, human being, human, and there they will implement the function work. In a class we don't need to have function keyword, so we just need work. That's important to know, because when we are not in a class, declare our function with the function keyword or as a arrow, fat arrow function. So it will be const work, and then we would have this in our fat arrow function like this. But in our case we don't need this. In our case it's in a class, so we do work. Again, it returns void. This is obviously it's only available in TypeScript, not in JavaScript, otherwise it will be like this. Anyway, we have an interface here, so we need TypeScript and human, and then work as well. There it will return void, and then we have another one and another one. But it's important to always use interfaces. That way you are following the open close principle. And single responsibility, we don't want to have our class to do thousands of things. If it does hundreds or thousands of things different, it will not be clear. It will just do everything. It will be really messy and it will be really hard to maintain. We can also call this spaghetti code. Is a anti-pattern. That means it's just not a good code. So we have to be careful, like in a function as well. Work has to only do one thing. So one thing and not something else. We have to see how we can split into little functions. Meaning if our function does more than one thing, it will be hard to split, hard to reuse elsewhere, and we will have duplicated code. If we are only careful of our code, how clean our code can be, and how one function can do only one thing, not more, then we will keep our maintenance and our code quality really high. Let's continue. It can eat as well. Indeed, a person needs to eat, so void eat. And then an animal does eat? Yes, of course, an animal can eat as well, so eat here. And then what else we will have? Work, eat, and maybe we might have a different class, another one. So we might need another interface animal here, and you will see why. So that interface, or we have to implement here extend, sorry. So this interface will extend from human, and in the animal interface we will have another interface. It will be birds, for instance, and you will understand why. Extends, and here to be animal. Why a bird? Because a bird can fly. So we have fly, it will return nothing, and that's our declaration in our interface. And here it will be a parrot, can obviously fly. A ibis, for instance, is a lovely bird, and we extend to bird, like a white ibis, for instance. Just ibis here, and then we have work as well. It will be the same. I will just copy paste, and then ibis can work and eat and can fly. So because we have the interface bird, it has to be implemented here, and then we will have our logic for the bird to fly. And you see, that way we have different interfaces, one interface for each of them. So in the solid principle, we have single responsibility, or for open close principle, then a list of substitution, I for interface segregation. So I will just show it to you on my phone. If I go to solid principle, okay, I hope you can see. So interface segregation is the third one, and after you have dependency inversion. So now we are going to speak about interface segregation. It means one interface shouldn't cover more than what it should cover. So human should be only for human, animal should only cover animal, and only the minimum methods a class should implement. It means if my bird doesn't have to work, why I should implement a empty work function? No, it shouldn't be the case. So the interface the class has to implement should only implement the minimum. So in each interface you should have the minimum amount of functions only for that purpose of that interface. It's much better to have the class to implement a lot of different interfaces rather than to implement one interface but then having to write 4 different methods in the body of the class, and 3 of them are just empty because that ibis or that bird class doesn't need them. No, just have the interface for little purposes, and that's it. So that's it for today. We will speak more in another video about the other principles of the solid principle. I hope it helps. Obviously, it's really important to always keep this in mind, to be able to write clean, neat, and easy to maintain code base, because otherwise it will be hard also to scale your code. Indeed, when you have a messy spaghetti code, you cannot really scale because you always have to modify everything. You have to change, you have to refactor your code base for years and years, and this is not what we want. We just want our code to be flexible but also closed for modification, but again open for extension. Oh, and just before I forget, it wasn't here extends but implements. Indeed, I don't know why, for some reason my ID was giving me some red lines, so it was just saying there was an error, but actually not. Since we are here writing in TypeScript, we have to use implements because it's not a class, it's an interface. So don't use extends unless you want to extend to from your class. If you want to extend to a different class, so from a class to different class, extends, you have to use extends keyword. But if you want to implement, so that's fine here if you want, or here, sorry, here it extends, but from our class we have to use implements like this, because we want to implement from the animal class, we want to implement human interface or bird interface. So there it has to be implements. And for the interfaces, when you extend your interface to a different interface, then you use extends keyword. See you in another video.